Hey guys, welcome to our channel. This is the first of many videos of the series How to Arduino. In this episode, we'll cover the ultrasonic sensor with the Arduino. So to begin with, what is the ultrasound? Ultrasound waves are waves with frequencies higher than the upper audible limit of human hearing, typically in megahertz. This ultrasound sensor has two piezoelectric devices. One of them is connected to plus 5 VCC. Upon being connected to plus 5 VCC, one of the piezoelectric devices has crystals in them that vibrate and produce ultrasound waves. These waves are reflected upon encountering an object, and the reflected waves travel and meet another ultrasound which receives these waves and produces analog outputs. The output given by this transducer is in microseconds. Now, distance. So let's talk about how this process works. The total distance is equal to speed into time. So speed of an ultrasound in air is 344 meters per second into time will give you total distance. Now 344 meters per second is converted into centimeters per microsecond into time. This is the total distance traveled by the ultrasound wave. Therefore, the distance between the object and the sensor is the total distance by 2. For this experiment, you'll need 4 male to female cables, one ultrasonic sensor, the HC SR04, one Arduino Uno, and a USB Arduino cable. Now the connections. The VCC is connected to plus 5 in the Arduino board. The triggering, which is for the first transducer that produces the ultrasound waves, is connected to pin number 12 of the Arduino board. The echo, which is the output, is given to pin number 11, which is an analog input for the Arduino, and the ground is connected to the ground in the Arduino board. Now let's look at the code.
Here we set the trigger and echo pin to respectively 12 and 11 as explained in the connection section of the video. We declare two variables. One is for the duration, the total time duration, and one is for the distance. Now in the setup function, we set the pin modes for the trigger and echo pin. Notice that we use output for the trigger and input for the echo. Now this is with respect to the Arduino. So the trigger pin is for triggering the ultrasonic sensor. So how we do that is by setting high and low in the IDE for the Arduino. So now if you go to the loop, there are two sections where we just set up the trigger input. Here we're taking low as off and high as on. Notice that delay microseconds means that it will wait for 2 microseconds, and similarly here it's for 10 microseconds. Now in particular for ultrasonic sensor HC SR04, it requires 10 microseconds to generate ultrasound waves. So here we set the trigger input high for 10 microseconds and then brought it to low. Now here this line duration is equal to pulse in echo pin comma h means that it will note down the time it takes when the trigger input is set high. So the second parameter denotes that whenever trigger is high, it will start counting the duration it takes so that the echo pin will give a high output, and you can find the total duration the ultrasound waves take to reach the sensor. Now explained before, we use the formula distance is equal to the total time duration into 0.0344 whole divided by 2, because we just want the distance between the object and the sensor. And here we're just using serial print to print it on the serial monitor. Now a way to open the serial monitor is by simply going to tools and clicking on serial monitor. Now you can see that these are the previous noted values that we had for the Arduino.
So now I'll be placing the object at 50 centimeters. So as you can see, the distance displayed is 48, 49, 50. Now we'll move it towards 30 centimeters. So now you can see that the distance has been changed to 30, 29, 30. Now we'll move it to 20. So you can see that it's 19, 20. Now let's see what happens if we place two different objects, that is one behind the other. So we placed one at 50 and the other at 30. So as you can see that the Arduino reads 30 centimeters as the distance.
Thank you for watching our video. Please like, share and subscribe.